Air valves, what are they and why do we need them? What's the big deal in properly sizing these on a pipeline? In this video, we're going to touch on air valve differences, along with point you in the right direction when it comes to sizing air valves. Hey, Jacob McGow, your Valve Ninja here to help you with your specifications, design requirements, troubleshooting, or acquiring needs. If you're new here, make sure you click that subscribe button to get notified of new videos. All the links mentioned within this video can be found in the description below, so let's jump into it. Alright, so air valve differences. Mainly we're going to be speaking of air valves used in the municipal industry, focusing around the AWWA C512 and AWWA M51 standards. Got a little bit of an introduction here. We are going to go over kind of types and purposes of air valves, some application examples, along with sizing, and then a little additional sizing bonus towards the end. So air valve types and purposes. There are three main air valves commonly used in the municipal side of things, both water and wastewater. We have our air release valves. These are basically releasing small amounts of entrained air at the high points. We have our air vacuum valves. These release large amounts of air during pipeline fill, during pump stops, which allows large amounts of air intake to occur to prevent a vacuum event. And then we have the combination air valve, which basically combines both functions of the air release and the air vacuum in one valve. These combination air valves can be offered in the single body style as well as a dual body configuration, especially when we get up into the larger sizes. So why an air release valve? Mentioned before, basically we have entrapped air that gets introduced naturally into the pipeline. A good rule of thumb, on the water side of things, potable water, we're going to probably, let's say mechanical equipment is going to put 2% air into the pipeline. So we're going to naturally have air just into the pipeline itself, and it will collect at those high points. So that's why we need the air release valves. On the wastewater side of things, it's a moving target. It all depends on the media and what's going on with the system as well, but it could have upwards to 6% though of air in the system. So air valves are definitely important on the wastewater side of things especially. So why an air vacuum valve? So during a pump stop, large amounts of air intake can take place to offer vacuum protection in the pipeline. You see on the kind of the cartoons there, we have our column separation happening out in the distribution system or maybe force main, and then it's going to come back resulting in a column rejoining. So we definitely need an air vacuum valve to address those issues. And then combination air valves, as mentioned before, we're basically combining the air release and the air vacuum valve into one. So this valve, when it is open, the air is exhausting during the pipeline fill, and then it will be closed when the pipeline is under pressure. And then when the pipeline is under pressure, the accumulated air will continually be released because we have that air release valve function performing. And then it will open again. Air enters during a pipeline drain or maybe a vacuum event. So other types of air valves also on the municipal side of things. What we're looking at here is more than likely on the potable water side of things, or maybe the reclaimed water. If we have a well system, we have a well service air valve offering that is in the market as well. There's two kind of flavors we can see here in the diagram. The one on the left, we have a diffuser screen inside of the air valve. And then the one on the right, the well service, we have that dual throttling device up top. Basically, we are throttling the air that's coming out of that air valve at a controlled rate. If a vacuum event happened, we got that little hood up top that is going to allow the proper amount of air back in to the air valve to protect the system. Additionally, our other types of air valves, we also have the surge suppression air valve offering, and then also a vacuum breaker air valve. Both of these have a specific application that they can be applied to. If you have an application where you think maybe you need some surge suppression or possibly a vacuum breaker, please reach out to your local favorite valve person, or feel free to reach out or comment and we'll get that addressed as well. So what we want to avoid, obviously we can see a tank. Same thing that happens to a tank can happen to a pipeline collapse. Basically we had a full vacuum event here that a proper air valve more than likely was not in place. So air valves specifically, when we're talking clean water versus wastewater air valves, there are some differences. Clean water, you're going to have on the left hand side in this, we're looking at 2 air releases. Wastewater, clean water on the left, wastewater on the right. The clean water is a short body. The wastewater, the body is lengthened and extended to avoid fouling of the mechanisms up top. The float generally has a skirted bottom, which is more receptive to the media inrush and prevents clogging, kind of keep the wastewater down below. Wastewater air valves, most manufacturers also will offer a stainless steel variant. These are offered in all sizes as well. Wastewater accessories, the most common is the backwash accessory kits. These are typically supplied for wastewater air valves to prevent as a preventative maintenance measure for maintenance for the operations to basically keep these clean and functional. Different coatings on air valves. This kind of goes along with hardware. Touching base on coatings, standard in the industry from all the manufacturers is exterior prime only. It's a cost thing. So one thing to keep in mind with air valves is we have air and then we have water. Most of the time these air valves are cast iron body. There are plastic offerings out there, but that's another subject. When we're talking about iron body valves, something to consider. We want to obviously keep the rust down. Most manufacturers also have standardized on 316 stainless steel internals to minimize any corrosion issues long term as well. But when we're talking about coatings of the valves, again, exterior prime only is the standard in the industry. There's also 2-part epoxy that's an offering, and then also there is fusion bond epoxy coating, which is also another offering. Trying to be non-biased here, I'll let the Salt Creek Sanitary District case study white paper be your judgment call. I will link I'll supply a link in the description below so you guys can read upon that as well. But hands down, I think you guys are gonna more than likely really lean towards the fusion bond epoxy coating when you guys do have air valves in your system. When you're talking about specifications, standards, these are things to consider. I mentioned hardware as well. So hardware, these air valves, they go into vaults. They're out in the open. Maybe they're exposed to the elements. It's not a lot of extra funds to standardize on stainless steel hardware for these air valves as well. So some applications, centrifugal pump application here. You can see the air valve is up top on the volute of the high point. So upon startup, a pump will cavitate. If large columns of air are present at the volute high point, the air will then be pumped into the system, creating efficiency issues along with surge problems as well. So to avoid these problems, pump manufacturers do recommend that the use of an air release valve is mounted at the volute high points. So this is a good application for an air release valve. Another application, combination air valves. Possibly we have a pressure filter tank. We want to do both air release and air vacuum at the top of those tanks. And then also we have our well service air valve in play here too. So this is a good example. The well service air valve is always upstream of the check valve, as you can see in the diagram here as well. Another application, maybe we have a high point, so we want to put an air release valve up there. There could also be a combination air valve there. It just depends on the application, what we actually are looking at. Air valve metering application, this is a good one. We want an air release valve there prior to possibly a metering device. The air valve or the air release obviously removes the air prior to the pressure reading to help increase accuracy. Sizing. Okay, so I think this is a really good subject to make everybody aware of, and I'll just read it right out. It is key to reviewing required vacuum sizing and compare this to what various manufacturers are capable of conforming to. We'll get into some details here in a bit. There are various tools also out there for everyone to view. ValMatic does have an online tool which is available. Some of these online tools are very conservative, so as a basis of design, run them. Then either the manufacturer, you can reach out to them, the local rep, or an application engineer can review and determine what may be able to be eliminated from the online tool, if any. Again, I'm saying some of these online tools, they are very conservative. But ultimately, it is best to perform a surge analysis to see what is really required. Some other sizing tools, again, ValMatic, they have their sliding scale. It's really cool. Customer calls in, we will ask, what the flow rates are. These are rule of thumbs, kind of do something really quick. Usually we're going to be pretty close in the ballpark of what's going to be required. Whether you're an engineer, end user, or you are applying an air valve, this is a great tool. Again, the manufacturers can help size air valves, and all the local reps as well can help size air valves. Theory, application, and sizing of air valves, kind of going a little further into it here. This is a white paper, and again, with the white paper mentioned, I will reference the link in the description below as well, so you guys can find this. But this is kind of a good thing to look at. One thing to point out here, I will say long horizontal runs, air release or combination air valves, typically we're going to find them at the 1250 to 2500 foot mark interval. We definitely want to make sure that we're keeping the air out of the pipelines, as well as having that air mitigation in play. Sizing. This is going to be the fun part. I'm going to switch over, and we're actually going to go into this Google Sheet, and I'm going to show you a few things, and I think it's going to be quite beneficial for everybody. Stay tuned. All right, we are going to talk about venting capacities for air valves, the famous Google Sheet. So let's jump into this. We got a few tabs across the bottom. Please note there are some, if you want to say, disclaimers or things to watch out for within this as well. But this is another good tool that you can use as a resource for air valve sizing. This kind of shows, gives a little more detail of what's required, let's say, for venting under a vacuum event specifically. So let's just jump right into it. Let's change some numbers around. On the left-hand side here, actually, I'm going to start off first here. This velocity conversion table is available within this link, this Google Sheet, I should say. I will also link down below in the description a link to this Google Sheet so you can get into this. But velocity chart, we'll get into this here in a second, and I'm gonna put a number together here for you. So let's do a little example. Let's left-hand side, these are things that we know about our system that we're going to design. So if we got a 12-inch size pipe, gallons per minute, we really don't know how many gallons per minute per se we're going to be flowing, so let's default to a 16 feet per second flow velocity. That is what, let's use them, also the most common gate valve, commodity gate valve in the market. Gate valves are the commodity isolation valve. Whether they are metal seated or most predominantly resilient seated today, governed around the C500, 509, C515 AWW standard. So if we look at the flow velocity chart, and then we look also for the 12-inch size within that, we're going to come up with a figure. We're going to plug in that 3917, it's already there. We get a required flow rate that the air valve must flow in SCFM for the air flow rate. So we got a number of 524. I would challenge, if you guys have standards also, whatever air valve manufacturer you're looking at, make sure it can flow that SCFM. You may find some manufacturers can do it and some manufacturers can't. And why they can't is maybe they have here's a little clue. Maybe the top of the air valve is the same for a few different sizes, so they are limited on what they can do for this flow rate because they have a one-size-fits-all basis. So taking this a step further, let's just kind of run through a quick exercise. We got our number, 524. We're gonna switch over to vacuum and exhaust sizing. We're going to put that in there, 524, 524. Come up with a 2.1 and a 2.3. Anytime we have a point, if you want to say, we always have to round up. So we're going to have a 3-inch air valve for this design criteria. Now, another disclaimer here, if we roll back here, there's no slope accounted for in these numbers. This is kind of going to get you in the right ballpark. And to confirm this, even if we look at our sliding scale that we talked about earlier in the video, we put in that 3917, it's about 4,000. We're basically right on the line, hopefully this works, of the 2 and the 3-inch air valve. So we're going to go with the 3-inch for this example. Again, this does not include slope, so that's one thing to take into consideration. I would also highly encourage, if you guys have, whether you're looking at specifications or even municipality standards. Some standards go by city, some standards also go by county standards. It might be in the best interest to move things over to a performance-based air and vacuum or combination air valve specification. Come up with the sizes that you have in your piping systems, and just come up with, hey, we want all our air valves to flow this SCFM, and that is the go-to for everybody. So when you guys go out for procurement, you are going to get an air valve that is going to work for your condition specifically, based around the performance-based spec. So that's the vacuum and exhaust. We also have a kind of a tab in here for air release. Kind of go through this as well. Mentioned earlier, when sizing these, you're going to put in your flow rates and then your percentage of air that you would expect. So let's just kind of go back. We had 3917. We're going to put in 3917. Let's say this is for potable water, so we're going to put it at 2%. That's the air release that we need to flow under this condition here that we just came up with in this example. So 10.2, depending on the pressures, we also need to consider that as well. we can kind of come up with our air valve series. In this case, 10.2, let's say we're doing 150 psi. We're going to have a series 22 air release. If it was just an air release only required, if it was a combination, then we need to make sure that we have the correct orifice sizing on that combination air valve as well. So a couple additional tabs to show throughout this tool as well. Again, that's ValMatic's example of their sliding scale tool that is out there. And then what are we looking at here? We got some links, some monitoring solutions. So these are just some interesting articles that I have within here. And another thing to consider is transient monitoring of systems, whether it's potable water or force main systems. This data can be utilized to help diagnose and see what may be happening in the systems themselves. You get a good resolution of what's going on, especially in the sewer force main systems. When we're talking about the potable water, you get that good resolution. Plus, you can also get a true timestamp of events, what's going on. And on the potable water side of things, basically you can bring in another aspect of things with a term called triangulation, which really, when placed or laid over with GIS data, basically you can pinpoint what's truly going on in the system. So that's something cool. That's a product that is put out by Cyrenix. One more tab here I'll touch on real quick. Hydraulic modeling surge analysis. We get into this with Charlotte a lot. They do bladder style and compressor style surge tanks, and they also utilize KY pipe and Bentley hammer for their surge analysis. Once they have a steady state model, then we can do more with that model itself for a surge analysis. So a couple of additional tools to kind of go over. Definitely, kind of wrapping this up. If you found this video informative, please like and share. To read a blog post on the importance of air valves, see a link in the description below. Until next time, cheers.